You know, our factories are getting smart, like really smart. They're automated, they're interconnected, and they are more efficient than we ever thought possible. But there's a dark side to all this new intelligence. The very technology that's powering this revolution, it's also creating the perfect backdoor for cyber attacks. So how do we secure the smart factory without sacrificing the smarts? Let's break it down.
Okay, so take a look at this. This right here is the poster child for Industry 4.0. What you're looking at is an automated guided vehicle, an AGV, and it's just gliding across the factory floor. But it's so much more than a robot. It's one piece of a massive, interconnected ecosystem where every single machine, every system, and every person is in constant communication. And it's all designed to make production faster and smarter.
And this brings us to the big question, right? The multi-million-dollar question. All this seamless connectivity is an incredible advantage until it's not. What happens when the very digital threads holding this whole smart factory together become its single greatest liability? All right, so let's dive into our first section, the connected factory's new risk. See, the technologies that are driving this whole revolution, stuff like the Industrial Internet of Things, or IoT, they've connected absolutely everything. But in doing that, they've also kind of accidentally swung open a massive digital door for attackers. This right here, this is the core dilemma. It's a total double-edged sword. Think about it this way. Every sensor, every robot, every single link back to the corporate network, it's another potential doorway. In the world of cybersecurity, we call this the attack surface. And in a modern factory, that surface has just exploded in size, giving attackers almost countless ways to get in and mess with actual physical operations. So, what happens when digital goes wrong? Let's talk about the real-world consequences. And I'm not talking about hypotheticals here. This risk has become a pretty grim reality. Let's just look at a few big attacks that show just how devastating this can be.
First up, Ukraine 2015. The country's power grid was targeted. Hackers used something called black energy malware to actually seize control of the industrial systems and just turn off the lights for hundreds of thousands of people. This was a wake-up call. It proved without a doubt that cyber attacks could have serious physical, real-world impacts.
Then, just 2 years later, the threat got even scarier. Hackers used a malware called Triton to get inside a petrochemical plant. And their goal was absolutely terrifying. They wanted to cause a massive explosion by disabling the safety systems. The only reason it didn't happen? A lucky bug in their own code. This wasn't just about turning things off. This was an attempt at digital sabotage that could have killed people.
Then we jump to 2018, and we see the financial side of this. A version of the WannaCry ransomware got into a huge semiconductor manufacturer. And here's the crazy part. It wasn't some super sophisticated, targeted attack. It was basically an accident, but it still managed to shut down some of their most advanced and critical production lines, causing a huge mess.
So what was the price tag for that one little accident? The company figured it cost them over $250 million. This proves that when we talk about securing a factory, we're not just protecting data on a server. We're talking about preventing a complete financial and operational collapse.
Okay, so that's the scary part. How do we fight back? It's not about unplugging everything, right? It's about building a factory that isn't just smart, but is also incredibly secure. And that all comes down to a clear 3-part playbook for what we call digital resilience.
So here's the game plan. It all starts with a change in philosophy, adopting a secure-by-design mindset. That means building security in from day one. Next, you need a technical framework, a blueprint, and that's where the industry standard ISA/IEC 62443 comes into play. And finally, you have to follow the law because new regulations are making all of this mandatory.
And that first step, the philosophy part, this quote just nails it. For years, secure by design was a buzzword, something people talked about but didn't really do. Well, that's changing. It's not a suggestion anymore. For anything considered critical infrastructure, it's an absolute necessity.
So what does secure by design actually mean in practice? Well, it means you're rigorously testing your systems for any flaws before they ever go live. It means security features like multi-factor authentication are turned on by default, not as an afterthought. And maybe most importantly, it's about a total mindset shift, from just reacting to attacks to proactively hunting for and managing risk before it becomes a problem.
Now, for that framework, ISA/IEC 62443 is pretty much the global benchmark. But what makes it so special? It's not for your typical office IT stuff. No, this was built from the ground up for the unique world of industrial automation.
the operational technology, or OT, the heavy machinery that actually runs our factories.
Look, I know what you're thinking. An 800-page standard sounds fun, but it's actually not that complicated if you think of it like building a secure fortress. The first part is just the general concepts, the foundational ideas. The second part covers policies and procedures, basically the rules for the guards. The third part is all about the system, the blueprints for the fortress walls. And the last part gets down to the nitty-gritty, the specific security for every single device, like the locks on every door and window.
All right, that brings us to the last piece of the playbook, and it's a big one: regulation. Governments are finally stepping in. There are new laws that now mandate strong security practices, and trust me, the penalties for not complying are getting serious. Over in Europe, there are two big new rules you have to know about, and it's easiest to think of it like this. The NIS2 directive is about securing the operators of critical infrastructure, the power companies, the water utilities, the transport networks. But the Cyber Resilience Act, or CRA, is about securing the products themselves. It makes secure by design a legal requirement for any connected device sold in the EU.
And hey, don't think this is some far-off thing you can worry about later. Just look at this timeline. By October of this year, NIS2 becomes law. By December, the Cyber Resilience Act is officially in force, and the really big obligations start kicking in by 2027. For businesses, the clock is ticking, and it's ticking loudly.
Okay, final section. How do we not just get secure today, but stay secure tomorrow? Because it's not enough to defend against the threats we already know about. Real resilience means adapting, both financially and technologically, for the dangers that are still just over the horizon. A huge piece of this is financial. The old way of doing things was called CapEx. You'd buy a big, expensive server, and then you were stuck with it for 5 years. But think about it. A cyber threat doesn't wait 5 years, it changes in 5 minutes. The modern way, OpEx, treats security more like a subscription. It's agile, it's flexible, and it means you always have the latest defenses, instead of being stuck with old hardware that's become a liability.
And speaking of future threats, let's talk about the next great threat, the game changer. I'm talking about quantum computing. We expect these machines to be so powerful that they'll be able to break the encryption we rely on for literally everything, from our bank accounts to our national security.
So, how do you fight a quantum computer? Well, you need a whole new kind of defense, and that defense is called post-quantum cryptography, or PQC. These are totally new types of algorithms, based on math problems so hard that even a quantum computer can't solve them. This is the next evolution of keeping our secrets safe. So, who should be paying attention to this right now? Well, essentially anyone who has data that needs to stay secret for a long, long time. Critical infrastructure is a perfect example, because here's the scary thought. Attackers could be copying our encrypted data today, just storing it, and waiting for the day a quantum computer can finally crack it all open. Adopting PQC is about future-proofing our most important secrets. And that really brings us back to where we started, with one final, and I think pretty critical question. The next industrial revolution is here, and it's being powered by connectivity. But that same connection brings a level of risk we've never seen before. The line between seizing this incredible opportunity and becoming the next cautionary tale is digital resilience. The only question left is your factory ready for it, or is it vulnerable to it?